of the sodium ion is 2, 8. And now if you look at oxygen, here the atomic number of oxygen is 8, the electronic configuration of oxygen is 2, 6, and the nearest inert gas present is neon with atomic number 10 and the electronic configuration as 2, 8. So, this oxygen to attain octet configuration like neon, it has gained one electron from one sodium atom and one more electron from another sodium atom. So, if you look at the colors, pink is the color of sodium ion, just taken for your reference, children. So, the electrons of oxygen are represented as green and the electrons of sodium has been represented as pink. So, what is oxygen doing here? It requires 2 more electrons to attain octet configuration. So, it takes up one electron from one sodium atom and another electron from another sodium atom, and thus it becomes an oxide ion. This oxide ion develops an ionic bond with both the sodium ions. So, sodium after losing one electron, it forms Na plus ion. So, O minus 2 ion gets attracted with 2 Na plus ions and thus forming a molecule called as sodium oxide. So, this is an electrostatic force of attraction present between the oppositely charged oxygen ion and the sodium ion. So, the type of bond present here is ionic bond. So, children, in ionic bond, electrons are transferred from one atom to another creating ions. Then the bond which is formed between the oppositely charged ion is ionic bond. And ionic compounds, they conduct electricity when they are melted or dissolved in water. So, the tendency of losing electrons or gaining electrons to form ions depends on the following factors: atomic size, ionization potential, electron affinity and electronegativity. Let us just define them. What is atomic size, children? It is the distance between the nucleus and the outermost orbit. So, as the electron moves away from the nucleus, the attraction between the nucleus and the outermost shell, it decreases. Now, what is ionization potential? It is the energy required to remove an electron from the outermost shell of an atom. Now, what is electron affinity, children? If an electron is added into the outermost shell of an atom, some amount of energy is released. So, ionization potential is the amount of energy required, absorbed by the atom to remove an electron. In electron affinity, it is the amount of energy released when an electron is added to the outermost shell of an atom. Now, let us define electronegativity. Electronegativity of an atom is the tendency to attract electrons. So, children, the atoms with low ionization energy, low electron affinity, high atomic size and low electronegativity, they can lose electrons easily and so they form cations. And the atoms with high ionization energy, high electron affinity, small atomic size and high electron negativity, they form anions. Children, please remember. So, which atoms can form cations? If they have low ionization energy, that means they can easily lose an electron with less amount of energy. Low electron affinity, that means if any electron is added, very less amount of energy is released. It has high atomic size, that means the gap between the nucleus and the outermost electron is very high. So, the attraction between the nucleus and the last electron decreases. Low electronegativity, that means it is having very less tendency to attract the other electrons and that means they can easily lose electrons. So, they form cations. Children, if the atom has high ionization energy, that means it requires a lot of energy to remove an electron, and if it releases a lot of energy to attract an electron, and if the atomic size is less, that means there is a lot of attraction between the nucleus and the outermost electron, and if it has a high tendency of attracting the electrons, then they can easily attract electrons and they can form anions. So children, after the electrovalent bond, that is ionic bond, G. N. Lewis has proposed that atoms of some elements could achieve an octet in their valence shell without even transferring the electrons between them. So, they need not transfer the electron from one atom to another atom. This is mostly possible in non-metals. They can attain octet configuration in their valence shell by sharing the valence electrons with one or more atoms. Let us see some examples. The covalent bond is formed by equal sharing of electrons from both the participating atoms. So, coming to the next type of bond children, covalent bond. How is this covalent bond formed? Here as I told you in non-metals, these non-metals they neither gain nor lose electrons, but when they are combining with the same entity, they mostly share electrons. So, children, when a bond is formed due to the sharing of electrons between the participating atom, then that type of bond is called as covalent bond. The pair of electrons participating in this type of bonding is called as shared pair or bonding pair, and the covalent bonds are also termed as molecular bonds. Children, sharing of bond pairs will ensure that the atoms achieve stability. So, why are they sharing the electrons children? To attain octet configuration, that means having 8 electrons in the valence shell, that is similar to that of noble gases. So, some examples are water. Here you can see that water molecule is made up of one oxygen atom and 2 hydrogen atoms. Here oxygen and hydrogen, they have shared one pair of electron. So, the type of bond which is formed between oxygen and hydrogen is covalent bond. Another example is ammonia molecule. Here one nitrogen atom combines with 3 other hydrogen atoms, and you can see that there is only one pair of electron which is shared between nitrogen and hydrogen. So, the sharing of electrons is taking place between nitrogen and hydrogen. So, what is the type of bond here children? Covalent bond. So, children, elements having high ionization energies, they cannot lose electrons because they have to absorb a lot of energy to lose that electron, and if they have very low affinity, then they cannot take up electrons. So, the atoms of such elements, they neither lose electrons nor gain electrons, but they tend to share their electrons with the atoms of other elements or with the atoms of the same element. So, children, covalent bonding can be achieved in 2 ways. One is the sharing of electrons can take place between the atoms of same kind. For example, H2, Cl2, O2. That means, here one pair of electron is shared between the 2 same hydrogen atoms. Here also 2 chlorine atoms have shared a pair of electrons. So, like that sharing of electrons between the atoms of the same kind can take place. Now, sharing of electrons between atoms of different kind. If you look at the example children, this is CH4, a methane molecule. Here the sharing of electrons takes place between carbon and hydrogen. Water molecules, ammonia molecule. So, let us start with an example, that is F2. F2 is a fluorine molecule. It is a diatomic molecule. That means, it is made up of 2 atoms of fluorine. So, what has taken place? Let us start with the atomic number of fluorine. What is atomic number of fluorine children? 9. So, how many valence electrons are present in fluorine? There are 7 valence electrons. So, how many more electrons it requires to attain octet configuration? It requires 1 more electron. So, it will share 1 electron with the same atom of the element, that is another fluorine atom. So, they come closer and then they share a pair of electron between the 2 fluorine atoms. 1 electron each they are contributing. So, if you look at this picture, this is the shared pair of electron. 1 electron is contributed by this fluorine atom and the other electron is contributed by this fluorine atom. The Thus, they are sharing one pair of electron between them, forming a molecule which is called as F2 molecule. And here the bond which is formed between the two fluorine atoms is due to the sharing of electrons. So, it is called as a covalent bond. So, in the first shell, in a fluorine atom you can see 2 electrons, and in the valence shell you can see 7 electrons. So, when two fluorine atoms, when they come closer, according to Lewis structure, children, you have to remember that one fluorine atom has to be represented in the form of dots and another fluorine atom has to be represented in the form of intos, and thus they share a pair of electrons and they form a fluorine molecule. So, what are these electrons called as? The shared pair of electron is called as shared bonding electrons, and there are 3 pairs of electrons in each fluorine atom which are called as non-bonding electron pairs. These non-bonding electron pairs are also called as lone pair of electrons. So, let us see another example, children. Oxygen molecule. An oxygen molecule is formed when two oxygen atoms, they combine with each other. So, how are they combining? Now, look at the atomic number of oxygen. Atomic number of oxygen is 8. The electronic configuration of oxygen is 2, 6. That means there are 6 electrons in the valence shell. So, we have represented them in the form of dots. So, when two oxygen atoms, they come closer, they share 2 pairs of electrons between them. And now, if you look at this oxygen atom, this has 8 electrons in the outermost shell. And now, look at this oxygen atom, it also has 8 electrons in the outermost shell. That means, each oxygen atom is contributing a pair of electron to attain octet configuration, and thus they are sharing 2 pairs of electrons. And when 2 pairs of electrons are shared, there is a double bond formed, because a covalent bond is formed when one pair of electron is shared. Then here, when 2 pairs of electrons are shared, 2 covalent bonds are formed between 2 oxygen atoms. So, this bond is called as a double bond. So, an oxygen molecule is formed by the combination of 2 oxygen atoms which share 2 pairs of electrons, thus forming a double bond. Now, look at this Lewis structure, children. So, each oxygen atom is contributing a pair of electrons, and then they attain, earlier they were having an electronic configuration of 2, 6. Now, after combining, now they have an electronic configuration of 2, 8. So, this is an oxygen molecule. So, this is a Lewis dot structure, children. 6 electrons in the valence shell, 2 oxygen atoms, they come closer, share a pair of, this is one pair of electron they are sharing, and this is second pair of electron they are sharing. Thus, they are forming double bond, 2 covalent bonds together. This is a multiple bond formed. As there are 2 pairs of electrons shared, we call this as a double covalent bond. Now, let us see another example, children. Children, nitrogen molecule. How is this nitrogen molecule formed? When 2 nitrogen atoms, they combine with each other, then a diatomic nitrogen molecule is formed. How is it formed? Let us see. What is the atomic number of nitrogen, children? 7. What is the electronic configuration of nitrogen? 2, 5. That means there are 5 valence electrons. So, you can represent them as N with 2 dots on one side and 3 dots on the other side. How many more electrons it requires to attain octet configuration, children? It requires 3 more electrons. As it has only 5, it cannot lose all the 5. So, it requires 3 more electrons to attain octet configuration. So, both the nitrogen atoms, they come closer. When they combine with each other, each nitrogen atom is contributing 3 electrons, and thus they are sharing 3 pairs of electrons. If you look at this picture, this is the first pair of electrons shared between 2 nitrogen atoms. This is the second pair of electrons shared between the 2 nitrogen atoms, and this is the third pair of electrons which is shared between the 2 nitrogen atoms. Thus, a nitrogen molecule is formed when 3 pairs of electrons are shared between the 2 nitrogen atoms. What is the type of bond formed here, children? A triple bond. This bond is formed when one pair of electron is shared, second bond is formed when another pair of electron is shared, and this is a third bond which is formed when third pair of electron is shared. Thus, we call this as a triple bond. So, let us see Lewis dot structure, children. Nitrogen atom with 5 valence electrons, when it comes closer, when it combines with another nitrogen atom with 5 valence electrons, each nitrogen atom they contribute 3 electrons, thus sharing 3 pairs of electrons and thus forming a triple bond. That means, here there are 3 pairs of bonding electron and each nitrogen atom has 1 pair of non-bonding electrons which is called as a lone pair. So, you can see lone pairs are also represented in this diagram. So, if you look at this picture, children, now this nitrogen atom when it shares 3 pairs of electrons, this has got octet configuration, and even this nitrogen atom after sharing the electrons, it has also acquired 8 electrons in the outermost shell. Now, it is stable with octet configuration, and so before combining with each other they had a 2,5 electronic configuration, and after combining the electronic configuration is 2,8. So, a nitrogen molecule is formed when 2 atoms of nitrogen combine with each other, forming a triple bond between them. So, triple bond is formed by sharing totally 6 electrons, that means 3 pairs of electrons. Now, look at another example, children, methane. Here this is the formula of methane, CH4. That means one carbon atom is combining with 4 other hydrogen atoms. Now, look at the atomic number of carbon, children, 6. That means the electronic configuration is 2, 4. 4 valence electrons are present in carbon and it requires 4 more electrons. Now, this is hydrogen atom with only 1 valence electron. So, carbon requires 4 more electrons and each hydrogen is ready to give 1 electron. So, totally how many hydrogen atoms we are taking, children? We are taking 4 hydrogen atoms. And so, when the hydrogen atoms and carbon atom, when they approach each other, each carbon is contributing 1 electron to 1 hydrogen atom. Thus, between carbon and hydrogen, 1 single pair of electron is shared. Here also, carbon is contributing 1 electron, hydrogen is contributing another electron, thus a pair of electron is shared between carbon and hydrogen, forming a single covalent bond. And in that way, each carbon atom shares 4 electrons, and now its electronic configuration has become 2, 8. It has attained octet configuration. And what about hydrogen? Now, hydrogen had only 1 valence electron earlier, but now taking each electron, 1 electron from the carbon, it has got duplet configuration like helium. And thus, look at this picture, children. Here carbon forms 4 covalent bonds. So, with 4 hydrogen atom. So, this is a methane molecule. Children, so this is a methane molecule. This is 1 covalent bond, 2nd covalent bond, 3rd covalent bond and a 4th covalent bond. But actually the structure of methane is not like this. This is like this. And why is it like this? Why are they forming a tetrahedral structure? We will be learning in the next theory. So, in this picture you can see 1 carbon is forming 4 single covalent bonds with 4 hydrogen atoms. Now, let us take another example, children, ammonia. The formula of ammonia is NH3. So, earlier we have studied atomic number of nitrogen is 7 with 5 valence electrons, and hydrogen has only 1 valence electron. So, hydrogen requires 1 valence electron, 1 more electron to attain duplet configuration, and nitrogen requires 3 more electrons to attain octet configuration. And thus, each nitrogen combines with 3 hydrogen atoms contributing 1 electron each. So, hydrogen atom is contributing 1 electron and sharing 1 pair of electron with 1 of the electron of nitrogen. So, nitrogen is contributing 1 electron to this hydrogen, 1 more electron to this hydrogen and 1 more electron to this hydrogen. And so, nitrogen is sharing 3 pairs of electrons, 1 each contributed by hydrogen atom. So, nitrogen now it has attained octet configuration, hydrogen has attained duplet configuration. So, this is the way nitrogen has got 8 electrons in the valence shell, hydrogen has got 2 electrons in the valence shell, and now this ammonia molecule is formed, and the formula of ammonia molecule is NH3, 3 atoms of hydrogen and 1 atom of nitrogen. So, if you see The pair of electron which is shared between nitrogen and hydrogen is called as bonding pair of electron. So, we have one single bond here, a second single bond and third single bond. Now, these are formed due to the shared pair of electron, and nitrogen has one non-bonding pair of electron which is called as a lone pair, and because of the repulsions between the bonding pair and the non-bonding pair of electron, the ammonia has got a pyramidal structure. And why it has attained a pyramidal structure, we will be learning it in the next class. Now, let us see another example, water. What is the formula of water, children? H2O. That means 2 atoms of hydrogen and 1 atom of oxygen. Let us see the atomic number of hydrogen again, 1. 1 electron in the valence shell. What is the atomic number of oxygen? 8. 6 electrons in the valence shell. So, oxygen requires 2 more electrons to attain octet configuration. And so, hydrogen is contributing 1 electron. Another hydrogen is contributing 1 more electron, and thus oxygen is sharing 2 pairs of electrons with 2 hydrogen atoms. And so, there is a single bond formed between hydrogen and oxygen here, and another single bond is formed between hydrogen and oxygen here, and thus a covalent bond is formed between hydrogen and oxygen. So, this is the water molecule which is formed due to the sharing of a pair of electron formed between oxygen and hydrogen. So, actually we expect that each pair of electron is shared between hydrogen and oxygen, and there are 2 non-bonding pairs of electrons in oxygen. So, it should be like this, but actually the structure of water molecule is not expected as linear, it is angular. And why? You will be learning it in the next class. So, children, let us see Lewis structure of water molecule. Hydrogen contributing 1 electron, 2 hydrogen atoms contributing 2 electrons. Now, oxygen atom, you can see it has 6 valence electrons, and now they are sharing a pair of electron between hydrogen and oxygen, and between this oxygen and hydrogen, and thus each line represents the sharing of 2 electrons. Thus, a pair of electron is shared between hydrogen and oxygen, thus forming a single covalent bond. So, this is the water molecule formed due to the sharing of electrons between hydrogen and oxygen. So, children, the total number of covalent bonds that an atom of an element forms is called as covalency. We have seen formation of single bond due to the sharing of a single pair of electrons between the 2 hydrogen atoms. So, a single bond is formed when 1 pair of electron is shared. So, hydrogen molecule has a single bond between 2 hydrogen atoms. Then what about oxygen molecule, children? You can see between 2 oxygen atoms, 2 pairs of electrons are shared. So, a double bond is formed between 2 oxygen atoms in a oxygen molecule. And in nitrogen molecule, we have seen between 2 nitrogen atoms, there are 3 pairs of electrons shared. So, a triple bond is formed between 2 nitrogen atoms. So, let us see what is the covalency. Covalency is the total number of covalent bonds that an atom of an element forms is called as covalency. So, what is the covalency of hydrogen here? One single bond is formed between 2 hydrogen atoms, so the covalency is 1. In oxygen, double bond is formed, so the covalency is 2, and in nitrogen a triple bond is formed, so its covalency is 3. Children, let us study what is bond length. Bond length, it is also called as a bond distance. It is nothing but the equilibrium distance between the nuclei of 2 atoms which is formed due to the covalent bond. How is it measured? It is measured in terms of nanometers or angstrom units. So, angstrom is written as A naught. Here 1 angstrom means 10 to the power minus 8 centimeters or 10 to the power minus 10 meters. It is also 0.1 nanometer or 100 picometer. What is 1 nanometer, children? It is actually 10 to the power minus 9 meters. So, bond length can be measured as it is very small, the length between the 2 nucleus of a bonded molecule, then it is so small that it is represented in terms of angstroms. So, look at this picture, children. A and B are the 2 atoms of a molecule, and this is the nucleus of atom A and this is the nucleus of atom B, and the distance between atom A and atom B nucleus is called as the bond length. So, a bond length of a covalent molecule is the gap between or the distance between the nuclei of the two atoms which have shared a pair of electrons. So, in this picture you can see this is a methane molecule actually. Here the bond length between the carbon and hydrogen is 0.109 nanometer, and in ammonia molecule the bond length between the nitrogen and hydrogen atom is 0.101 nanometer, and in water molecule the bond length of oxygen and hydrogen atom is 0.096 nanometers. Bond length of oxygen molecule, in this oxygen molecule two atoms of oxygens are sharing two pairs of electrons. So, the bond length is 1 to 1 picometers. Pico means 10 to the power minus 12 children. In hydrogen peroxide children, the bond length is 148 picometer. In nitrogen molecule, the bond length is only 110 picometers, and here between the nitrogen and nitrogen the bond length is 145 picometers. Now, coming to the next topic children, bond energy can also be called as bond dissociation energy. The word itself is telling that it is the energy required to break a covalent bond. It is a strong bond which is formed due to the sharing of electrons. So, to break the bond we require some energy, mainly when the two atoms which are present in a molecule are present in the gaseous state. So, it is measured in the units of kilojoules per mole, and if you look at the bond energies, here F2 is fluorine molecule, and the energy which is required to break the bond present between the two fluorine atoms is 156 kilojoule per mole, and if you want to break the bond present between the two chlorine atoms in a chlorine molecule, it is 243 kilojoule per mole. So, in this way the bond dissociation energy to break the two chlorine atoms is 59 kilocalorie per mole. So, there are some drawbacks of electrovalent theory also children. What are the drawbacks? The bond length and the bond energies were not expected as the same. Even the atoms which are sharing the electrons, they were not having the same structure as expected, and practically it was also observed that the bond lengths and the bond energies are not same, they are different. For example, if you see in beryllium chloride, if you look at the picture, here the bond angle between them is 180 degrees. So, this was not explained in the theory. The bond angle in BF3 is 120 degrees. So, BF3 molecule is this, it should be expected like this, but here it is not as expected. It forms a trigonal planar structure like this with 120 degrees angle. And now, if you look at the picture of methane, here we expect all the 4 hydrogen atoms surrounding the carbon atom, but the structure is tetrahedral and it forms a non-polar covalent bond, no charges on any of the atoms. So, why it was not explained? Even ammonia molecule, here the bond angle is 107 degrees. So, why is it like that? It was not explained. In water molecule, the bond angle was 104 degrees 28 minutes, and why is the bond angle decreased was not explained. So, these are all the drawbacks of the theory. So, let us recall what we have studied in what we have learnt points children. Children, the outermost shell of an atom is called as valence shell, and why do the atoms they combine with each other? To attain octet configuration. So, which atoms they combine with each other? Only the chemically active elements which do not have octet configuration in the valence shell. So, a covalent bond is formed when the electrons are shared between them. Each shared pair of electron is called as a covalent bond. Electrons are not always shared equally between the atoms in covalent bond also, and that is why we have seen some examples where some molecules were polar. Children, please answer these questions. What is octet rule in improved learning? How do you appreciate the role of octet rule in explaining the chemical properties of elements? Write about the formation of single bond, double bond and triple bond with the help of diagrams. Children, please download the worksheet from SIET website for better learning and good practice. Okay children, so I hope you have understood the lesson. Let us meet in another interesting session of chemical bonding. Thank you.